Also, his research includes the fundamentals of algorithms and mathematical modeling. He has around 29 national and international research papers. He delivered guest lectures, expert and invited talks in FDPs and training programs. He received RPS grant from DRDO, DRL Tejpur, India in 2015. Sir is currently working on the project funded by JNTU Hyderabad Tech 3 Hyderabad. He is also associated with the development of a machine learning based diagnostic tool for malaria diagnosis. He received Award of Excellence from IIT Bombay in AACTE FDP program, IIT Bombay in 2016. Dr. Madhu sir has delivered a lecture as a resource person in refresher course on nonlinear analysis for the development of neural network system organized by UGC Human Resource Development Center. Dr. Madhu sir, he is also a reviewer for IEEE Journal of Biomedical and Health Informatics. And also he is a reviewer for Journal of Experimental and Theoretical Artificial Intelligence. He is a reviewer for Multimedia Tools and Application, Springer Journal, and also reviewer for Soft Computing. With this long list of achievements, let me call upon Dr. G. Madhu sir to take over the session and deliver the talk. It's a hands-on session. So this session is on CNN model for NLP. Sir,
Yeah,
we request you to take over the session. Over to you, sir.
yeah. Thank you, ma'am. Thank you, madam. I'm audible to you?
Yes, sir. Yeah.
Yeah, fine, ma'am. Thank you. Yeah. Can you see my screen, everybody? Good morning, everyone. Good morning, everyone. I'm audible.
Sir, you're audible, sir. You can continue the session and your slides are also visible to participants.
Fine. Thank you, ma'am.
Sir, as per your request, we have sent a drive link for the data set in the Google Meet, and also we have forwarded that link in the WhatsApp group, sir.
Fine, madam.
So participants can access that link for a view of the data set.
Fine, madam. Thank you,
Yeah,
ma'am.
thank you, sir.
Thank you so much. I welcome you, all the participants in the workshop today. So, what is our aim of today is I'm going to explore the convolutional neural networks for natural language processing. So while implementing a natural language processing, mainly we are concentrating on text classification. So here, convolutional neural network can be used to find the general patterns in the text documents or any kind of emails, any kind of classification system, text classification system. Completely we are concentrating on convolutional neural networks to perform the classification task on text documents. So the main intention of this convolutional neural network is to find the hidden patterns in the text. So this is the motto of today program. So in my today talk, I'm going to cover the content is introduction to convolutional neural network. Then I'm going to explain the what is a text classification, why it is important to us. That is also one of the aspect I'm going to cover, the convolutional neural network versus the text classification. Then we are going to use the some dynamics to understand the convolutional neural network, how to fit into the model of a data classification system. So this is what main agenda. So finally, I'm going to give the hands-on session, text classification, that is the customer reviews with the help of convolutional neural network. This is the main agenda of today program. So before dive into the program, I want to give some a demo for this program, CNN values. Recently here, can you see my screen, everybody?
Yes, sir.
Yeah. So before going to, so I'm going to give the importance of this text classification, why text NLP is important to us. So artificial intelligence, recently Google Brain have been developed a Lambda. Google people have developed one Lambda, that is a language modeling of dynamic dialogue applications.
Madhu sir, any problem?
I want to share one video.
Okay, sir.
Yeah, so I want to share video and I'm unable to getting link over here. That purpose and I'm searching. I want to share some video and audio also to you.
Okay.
So first I will quit the scaling program. Yeah, can you see my screen with the audio?
Still no, not useful. You are not sharing anything.
Yeah, can you see my screen, Amma? Is it audible to you and is it visual to you? The screen video lecture.
No, sir. 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 No, sir.
Could you respond from audience? Anyone? My video is visible to you and my audio is audible.
Madhu sir, no video, no audio. Just disturbance వస్తుంది చూడండి ఒకసారి.
Okay. Okay. Okay, fine. So it is not feasible to me to share my videos to you, and I will continue my lecture. Yeah. Yeah. Now you can see my screen.
Not visible, sir.
Now.
Just now it's okay, sir.
Fine.
Okay, sir. Okay.
So welcome to all the participants. So today I'm going to cover the concept of convolutional neural network for natural language processing. So before dive into this program, first I want to give some introduction about convolutional neural network and the roots of the convolutional neural network. Okay. So here, generally, convolutional neural network is main intention is computer vision problem. But in the convolutional neural network, every image is represented in the form of pixel values. See here. So this is it is an image. That image is transformed into a pixel values. That is transformed into an array of pixel values. So that is the input of the CNN model. But in the context of text classification, this image is not fit into our model, right? So what kind of network we are going to take? So first we are going to write the documentation sequences. Then we are taking a CNN model. So that is sequence are transformed into a tokenization. After tokenization, we are going to transform the embedded systems, embedding forms, embedded words. Then we have to make sure that while forming all these embedded words and embedded sequences, this is the input to the CNN model. For the purpose of images, you can represent in this form, but the text is not like this. So I will teach you next slide. So how it is happening here. So before that, what is convolutional neural network? Many of them adapting technology, implementing convolutional neural network. Exactly what is convolutional neural network? It is a variant of deep feed-forward neural network. It is a one kind of variant. It is a variant of deep feed forward neural network, which has been applied for analyzing the visual imaginary in the field of computer vision and natural language processing and other areas. So here we are concentrating how CNN have been applied into the natural language processing. This is the image. So here your input is a cat. So then I'm going to implement that. Input is a cat, then that is transformed into a pixel values. Then that is the input to the convolutional layer. Then followed by pooling layer, followed by dense layer or fully connected layer, then followed by a cat layer. These are the architecture. This is the one illustrative example of your complete architecture of CNN model. Okay, for the image purpose is this one. But what about text classification? This is the image. So image is actually in image we have so many channels. So RGB channels we have 3 channels. So 1 or 2 channels, 3 channels you are maintaining. From the 3 channels, first part is you are going to extract the lower level information with the help of convolutional layer. Then followed by we are pooling the maximum information about the first layer. Then we are performing the again convolutional layer. Similarly, we are performing the max pooling layer. Then we are performing the non-linear function. Then we are performing the for dense layer, that is called fully connected layer. Then we are put into the finally classifier. This is what happening in the convolutional layer, right? So coming to that, exactly what do you mean by convolutional layer? Convolutional layer is nothing but multi-layer neural architecture. It is multi-layer neural architecture. So this is the thing. See here, I have an input image. That input image, I am taking a partially information about the image that is transformed, that is feed into the data into the first layer. So that is, we call it as a feature map. So in the feature map, we are doing a convolution operation. That convolution operation can be viewed as a window. So that means you have to move to the left to right. We have to move to the left to right convolution operation with the help of filters. Then it will read the information about the input image to transform the feature map and it will help the identify the lower level features of the your input. So then followed by linear function, non-linear function. Then we are doing some subsampling. This is what we are calling a feature maps. Finally, we are taking highest information of that input image. Then followed by convolutional layer, then followed by feature map. This is the what happening in the convolutional neural network. This is the complete structure is feature extraction. This is the classification system. But this is happening for image. But we are not interested to do this image formation. We are interested how to implement convolutional operation for text document, text classification, NLP. That is our motto. Okay. So first I will give the introduction of this convolutional, then move to the convolutional neural network for text classification. But this convolutional neural network was invented by LeCun. This is the pioneer work I have done by in 1988. So the LeNet was the first convolutional neural network, which helped so many people in the industry in the field of deep learning. So at the time of LeNet, the architecture was mainly purpose is character recognition. The LeNet is constructed for the recognition of characters and reading the zip codes. So that is the purpose. This is the paper have been published on behalf of this work, gradient-based learning applied to document recognition, LeCun and others. This is the architecture of LeNet. The input is 32 into 32 into 1. 32 is nothing but height, width, and 1 is nothing but a channel. So 5 cross 5 is nothing but a filters. S is nothing but your stride. I will go in detail about what is mean by filter, what do you mean by stride, and now we are performing convolutional operation and everything. While coming to the LeNet, we have an input image, then followed by filters, then followed by first convolutional layer, then pooling layer, then convolutional layer, then convolutional filters and convolutional layer, then pooling layer, then convolutional layer, then fully connected layers. Then we are finally substituting all this information to the soft function, then we are going to predict the model is it is a digit or not. That is the purpose only LeanIt have been invented. This is the primary work for any kind of deep learning to implement in our own approach. Okay, this is the behind history of LeanIt. So coming to that, in our CNN, so in the text classification, one of the first CNN model from Stanford University. This is the model. This is the model, a convolutional neural network for modeling sentences. This is the first paper for text classification. This model is used by the dynamic max pooling operations. So we are calling it is a DCNN. DCNN, and also Department of Computer Science and University of Oxford people have been published the first paper in terms of convolutional neural network for text classification. Okay, why CNN is important to us? Why we do study convolutional neural network? Because recently, not only recently, many of years people are using the terminologies artificial intelligence, deep learning, but the basic implementation of this deep learning approach is CNN. That CNN is progressed rapidly. Real world applications are deployed into the models by computing resources and memory constraints. But CNN are usually popular because of their architecture, and best thing that means you can fine tune by your own model. Similarly, there is no need separately to calculate a feature extraction model like machine learning. To overcome that problem, we are utilizing this concept. The system may learn to do feature extraction and core concept of CNN, which is used to convolution of the words and filters to generate invariant features of your text documents, which are passed one layer by another layer. So this way we do extract the feature. That purpose only we study this CNN algorithm. Okay. So before dive into that, what is convolutional operation? What do you mean by a convolutional operation? Coming to that, in terms of mathematics, convolution is nothing but it is a kind of two functions. The two functions are, what are the two functions? Your input is one function, your kernel or filter is another function. Your kernel is one function, your input is another function. These two functions are going to produce a new function. That is what we are calling a convolution. Convolution is nothing but it is a mathematical operation of two functions that will produce a third function that express how the input is modified by another new function. So this is the mathematical equation. The term convolution has referred in terms of mathematical function y of m comma n, x of m comma n into h of m comma n. So what do you mean by that? M and n are, you know, that your row and column matrices. Okay. So this way we are going to produce the mathematical equation for convolutional operation. Okay. So your function is very simple here. X is nothing but input image. H is nothing but your filter. In the equation, X is represent input, your input value. That means your text documents. H is nothing but a filter. Okay. I comma j are nothing but these are the, so here m comma n are there in the left hand side. M comma n are represent rows and columns, m rows and n columns. Okay. CNN are very similar to your ordinary neural networks only. Here, each neuron receives some input to perform multiplication, matrix or dot product, and you are following non-linearity and producing the results. CNN comes with under the category of artificial intelligence only. Here, am I audible?
Yes, sir.
Yeah. See this one. This is my input, A, B, C, D. So I'm taking one illustrative example here. I'm going to represent. I have A, B, C, D, and E, F, G, H. So represent A nothing but your document word significantly. We are representing some value. A is represented 1, B is represented 1.5 something. So that is your input value. Okay. This is my input. Then followed by kernel. but this is the purpose of image computation. So it is a two-dimensional convolutional operation without kernel flipping here. See here, a into w plus b into x plus c into y plus f into z. So this way I am taking that one. A, B, E, F. This is the portion I am going to compute with the help of kernel. How I am computing this one? This is my output, first output. Similarly, just move to the one slide. This is a slide window. Just I am moving the one slide. Second results I am getting, second output of this kernel versus input. Input is nothing but your x value. Kernel is nothing but your h value. Then I am producing a new value of this output. This is what we are calling a convolutional operation. This is the convolutional operation, 2D convolutional operation, right? So now, coming to our text classification here. See, you people are working with your text classification. You are aware of the definition also. So convolution network we are applying on text classification. So even though I am going to give the small definition of text classification, it is nothing but a process of assigning a labels to the set of text or words or documents with the help of either 0 or 1. Okay, so this way we are calling it is a text classification, also known as text tagging, also known as text categorization. Text categorization is nothing but it is a process of providing, it is a label. You are providing a label of particular word, label of particular sequence, label of particular text, either 0 or 1. Okay, and those labels will tell us what is the sentiment of that set of words. Why do we classify this data? To know the sentiment of the particular word. That purpose only we are performing this classification task. Okay, this is what we are calling classification, text classification. Then how do I fit into the model text classification? See, my input is text documents. I have a one sequence. I have a sequence. I am surprised to see a remix being promoted over the original. This is my sentence. I have a sentence. Then I transformed my sentences into a word vector. Okay, so that word vector, it is a embedded vector. So after taking a tokenization and all these things, which is the input to the your CNN model. So after you have a word vector as an input, then perform a convolutional layer. This is what convolution. What I am doing here, convolution. Convolution operation can be viewed as a window-based feature extraction. Here, convolution operation can be viewed as a window-based feature extraction, where the features are patterns in the sequence of the word, patterns in the sequence word, grouping that. What I am doing here, grouping that, which indicate that sentiment of the text. The main intention is to recognize the patterns, to recognize your sentiment of that particular word. Okay, so this way we are going to perform a convolutional operation here. Convolutional operation, then followed by pooling layer, then followed by a pooling layer, then followed by a connected layer, then classification. This is the various stages we have while performing a convolutional neural network for text classification. I hope you understandable the concept of how to implement a convolutional neural network for text documents or text any kind of sequences. Fine. Why we do study this text classification? What is the main intention, sir? The question is, most of the real world information, 80% of the information is unstructured. Why we do this classification with the help of this convolutional neural network means most of the information, 80%, okay, unstructured, with text being one of the most common type of unstructured data. Because while we are writing emails, while doing chartings, so while doing kind of preparation of your documents, all these belongs to category of text. So that is one of the primary intention to classify the data, and we want to know the hidden patterns in your text, and we want to know the sentiment of your text documents. So that purpose only we do this classification. That purpose only we are studying this concept, convolutional neural network for text classification, because the massive nature of text, analyzing, understanding, organizing, everyone doing that one only with the help of machine learning also. Okay, organizing, understanding, sorting through the text data, hard and time consuming. Because see, so you have a text document, only one document, two document only you can visualize and you can verify the credentials. But apart from that, you have a complete 700 pages or 1000 pages are there. So that time it will take a very hard to understand the sentiment of the each word, and that may be time consuming. So therefore, most of the companies fail to recognize the sentiment of the each word in the document. So that is the purpose only this machine learning and artificial intelligence came into picture. Okay, this way text classification with machine learning, right? Using a text classifier, companies can what is the benefit of this artificial intelligence and machine learning? Automatically to perform the sentiment task, sentiment analysis, to perform the sentiment analysis with the help of key phrases, relevant key phrases from emails, your legal documents, social media, chatbots, surveys, and other applications. So that purpose only we do study a text classification. I hope you understandable why it is important to us. Okay, so here I'm going to give a small glance of that. It is the left hand side you have a structured data, in the right hand side you have a unstructured data. So many people are using the word is unstructured data. Exactly what does it mean? What does it mean? Unstructured data. So that means even though your text document cannot be displayed in rows and columns, your data cannot be represented in terms of rows and columns. So that kind of data we treated as unstructured data. Okay, any kind of relational databases is nothing but unstructured data. Many MNC companies are maintaining relational databases only. Many companies are maintaining their data in terms of relational databases only. The data have unstructured, then we cannot find the hidden patterns, we cannot perform the sentiment analysis on that place. So due to that reason, we are adapting these technologies. Okay, so this is what relational database is, the one flavor of unstructured data. Your image is nothing but unstructured data. Audio and video is nothing but unstructured data. These are all unstructured data flavors. Okay, I hope you understandable what does mean by unstructured data. This is the left hand side, you have a structured data.
Good morning, sir.
Yeah, please.
Sorry to disturb. Sir, actually images, we take it as a two-dimensional matrix, no, sir. We are representing by rows and columns only, each pixel values and intensities. So for all image processing applications, transformations and all, we do it as a matrix operation, no, sir.
Fine.
So it can be represented as a two-dimensional grid. So how it is actually unstructured, sir?
I'm going to explain to you, sir, because we are not representing a two-dimensional, we are representing a one-dimensional convolutional operation for text classification. I'm going to perform the single operation here. If you have a one or more layers, then you have to perform two-dimensional. Krishna Garu, are you understandable?
Sir, you said image cannot be represented, like anything cannot be represented rows and columns, that is like unstructured. You just now gave in that slide.
Relational
but
database.
Image actually is represented as rows and columns only, no, sir. It
So
is
when
defined as a matrix only. That's
Sir,
why I just asked.
Correct only, Krishna Garu. While storing an image, you are not transforming image matrix notation, no? You are watching a video, or you are taking some pictures, which is not transformed into directly in matrix form. When you are feeding it to the artificial intelligence or neural network or CNN model, then only you transforming purpose of to feed the data into the model.
Okay.
So normally we are not doing any kind of matrix operation on that place.
Okay.
I got you. I hope you understandable my question. Am I right?
Yeah. But normally when we study image processing books or anything like that or any such things, we automatically take, even in MATLAB also, we take it as a matrix and then image reversal or histograms or anything. There also we take it as simply a matrix and then do the
Correct.
operations.
Correct.
That's
Yes,
why
correct. Yes, Krishna Garu, that you see, image, it is maybe image or it may be text or any kind of things, you need to transform only matrix notation. Then only your model is understandable. Otherwise, you cannot. Everything you need to transform into a matrix form. Either image data or text data, any kind of data.
That's why I thought it is a structured one, sir. That's why I was just having that confusion.
Yeah. See, while storing, it is unstructured. While feeding, it is a structure. It is a structure.
Okay.
Okay, thank you.
Sir, I have a query too.
Yes, ma'am, go ahead.
Sir, in the previous slides, you have shown that there are two functions f and g, and but I got is one function is a dependent function and another one is the independent function. And same is the case with all the equations, either we talk about linear equations or anything else. So what is the difference between those equations and this convolution?
Yeah, I will take one example, ma'am, and I will explain to you. You got my point here. I will take one function, input function. The input function is text image, text document. Then I will take a kernel. So these two functions I am going to perform on behalf of you, understandable, right?
Okay, sir.
How do I classify? I will tell you. 1 minute, I will tell you. Okay, this is the things. Yeah, so this is the traditional approach while calculating your documentation. So in the machine learning, what we do is we are taking feature extraction, feature selection, and vector representation, and we are applying support vector machine or navigation applications or decision trees or some kind of application. This is the traditional method. Coming to deep learning approach, we are going to consider a document only read as a document, that is the input. Then we transform the document into a tokenization. This tokenization responsibility is transformed into your vector notation. Then we are applying your network model, either CNN model or RNN model or any kind of neural network. And parameter tuning, then we are classifying the data sets. This is the glance of differences between machine learning versus deep learning for the text classification. Okay. So many people are not clear for how you are performing a convolutional operation on your text document. That is the question, right? Yes, madam. Jane, madam, you asked me that one only. So these are the dynamics in the convolutional layer. We have first dynamics is convolutional layer. In the second one is a rectified linear unit layer. And the next one is a pooling layer. Next one is a fully connected layer. So these are the various types of dynamics in the CNN model. So here, madam, could you clearly see here what I am doing here? So my input is this one. The food was very delicious. The food was very delicious. So that is my sentence. What I did is I have taken a tokenization help and I transformed my data, my sequence data into this matrix form. Madam, are you able to following me?
Yes, sir. But how we have converted it into the matrix form? The word is THE and there is delicious. So
Yes,
number of characters are different in each word.
Yes, madam. We are doing a inverse TF frequency, term frequency. With the help of term
TF
frequency
and IDF.
IDF also we are going to do. But we are not performing here IDF and TF because we are performing a convolutional operation. So I will explain you in terms of coding also to you. Because we have a hands-on session, how I am taking a input is this text document, how I am performing a text document into the model. Because I have this is the food was very delicious. This is my input. So I am transformed this input into this form. This is called embedded size, embedded form. How you are transforming your text documents into embedded form with the help of tokenization. With the help of tokenization, we have a separate module in the convolutional layer. Separate module, we have one function in the tensor flows, embedded function. That function will take care of to transform all these things. No need to separately to calculate term frequency or inverse term document frequency also.
Okay, sir.
Okay, so here what I'm doing, ma'am. I'm taking a kernel size is 3. So here kernel size is 3. That means 3 rows. So that vector is C4. It is 4. So 4 by 3 here. So now I am taking this kernel window on this input image. See, not image. It is the input sequence. This is a Word document. This matrix. I am taking. So top to bottom, top to bottom. See, madam, it is a some color is there, no? Empty cells are. Can you see empty cells over here?
Yes, sir.
So empty cells means there is no information in the form of that cell. So what I am doing here, that there is no information. I am writing 0 into 0.2 here. So see this one kernel 0 into 0.2
Right, sir.
plus 0 into 0.4 plus 0 into 0.5 plus 0 into minus 0.1 plus second row.
Multiplication is clear to me. That multiplication is clear to me.
Okay, fine. So based on this multiplication, I'm going to generate a feature vector of this input value.
Fine.
Feature vector. I'm generating a feature vector. So can I move to the second slide? See this will, I'm generating second one. Just I move to the one slide. That is called stride. That is called a stride. I just move top to, so next to the second one. See, previous one is, I have taken this one. Just I moved one position of the cell. So one position of the cell, first row only, empty remaining values may be computed in this terms of this one. This is the feature vector. While calculating this 0 into minus 0.2 plus 0.4, 0 into 0.4 plus 0 into 0.5 plus 0 into minus 0.1 plus 0 into 1 into 0 minus 1, all computations are occurred in together. We are going to generate a new feature vector here. See here, 0.2, 0.53, we need to generate. This is the feature vector of your text document. This is the feature vector of your text document. I hope you understandable how I am generating this.
Yes, sir.
Yeah, so like this, you continue embedded size, you continue this way, you are going to generate this 4 by 4 now, 1, 2, 3, 4, 5. So you can generate feature map also same size. 1, 2, 3, 4, 5, 6, 7, right? So you continue like that, you are going to generate this one. So what you do that after generating a feature vector, we are supposed to select highest information, maximum information in this vector notation. So this is what happening your simplification of your word vector. This is the word, then followed by convolutional operation with the help of filter. Then we are generating row 1, row 2, so on row n. This is the filter responsible or convolution output of the convolution operation. I hope everybody understandable how I am performing a convolutional operation. This convolutional operation can be viewed as a window-based feature extraction. This convolution operation can be viewed as a window-based feature extraction. The features are extracted. So that means we are identifying a hidden patterns in the input. So that means we are going to recognize the sentiment of that particular word. That is the main intention of this convolutional operation. I hope everybody understandable this convolutional operation. That is the first dynamic of your convolutional neural network. Okay. So now question is
there any rule to decide the window for the filter?
Yes, madam.
Sir, always the kernel size window always been a odd number, right?
Yes, sir. It is a 2 by 2 also you can take, but most of the people are taking a 3 by 3, 5 by 5, 7 by 7 like that. Then only the model performing very well. You can also try. So we are trying now. We are taking a kernel 3 by 3. You instead of 3 by 3, please try to 2 cross 2. What will happen? Check out and get back to me. I will demonstrate that example to you.
Information loss will be there, sir, if we're going to take the 2 by 2 or 4 by 4.
Yeah, because we are going to lose some spatial information. Yeah, spatial information about the matrix.
So we need to add padding for that. If
that is also I'm going to explain you. So that purpose only I have taken this padding. See here, this is padding, nothing but. So I will explain to you that padding also to you.
So in the example you have seen that I have seen that that is the 3 by 3, but
yeah, that's 3 by 3. I did not apply any kind of padding here.
Yeah. So your kernel window size is 3 by 3, but you have taken 3 by 4. Here also the size of matrix also 3 by 4. So directly you are applying this 3 by 4 to this 3 by 4. How it is possible?
But input size is 4. My input size is 4.
Okay, input size is 4.
Yeah.
Yeah, input size is 4, but the kernel window must be 3 by 3, right?
Yeah, you can
So,
also perform, sir. So there is no restriction here, but understanding purpose, I am demonstrating kernel is 3 by 4 here. You can take 3 by 3 only while performing your experimentation. For understanding the computation, this addition and multiplication, that purpose only I am representing this one.
okay, sir.
Okay, so these what are the filters and kernels in the CNN? So in the convolutional net, very interesting here, filter one of the hyperparameter of your CNN. Sir, how kernel can be fixed in the model? Kernel, we are not initializing kernel. We are only representing how many kernels are required. I need 32 kernels. I need 100 kernels. I need some 50 kernels or something. So maximum kernel size is 951 for text classification. 951 is the maximum kernel size. Okay. However, CNN does not learn filter here. We must design yourself. Keeping in mind your input data, dimension, and output is required. So that is the main important. Keeping your input requirement, your input dimension, because in the previously I have my dimension is 4 by 4, and that purpose I taken 3 by 4. Otherwise, not required that 3 by 3 only enough, and that output is required. The convolution is kernel. Convolution is using a kernel to extract the certain features of your input value. Either it is input is image or your document. Convolution is using a kernel to extract some features or certain features from your input model, right? Kernel is nothing but it is a matrix. It is a slide across your matrix and multiplied with the input such that the output is enhanced certain desirable manner. The output is enhanced in a certain desirable manner here. Okay, ma? So that purpose only we are taking this kernel purpose here. Okay. So previously somebody asked me, sir, you have taken a text and then now you are representing that one is a numerical form, some values 0.1, 0.7. That is called a word embedding system, which are the method to represent word as a vector that carry some meaning of your model, which allows the word similar to meaning to have a equal representation. Equal representation. For example, the word here happy and excited, which are often used to same context. So thus the word will have similar vector representation. This is what we call a word embedding model. Okay, so the difference is kernel and filter, and I skip this one if this is not required. So people are asked to me pooling layer. What is pooling layer? How you are pulling the main information from that feature vector. So pooling layer is nothing but it is a building block of convolutional layer. It is a function to progressively reduce the spatial size of your representation of input. Main intention of this pooling layer is to reduce the size. That means dimensionality reduction. You have a higher dimension, you are transforming your data into a lower dimension without losing information. Spatial size of representation to reduce the amount of parameters and the computations of the network. So this is the reduce the number of parameters. Okay, when text is too large, reduce the number of parameters. When text is too large, that pooling layer operates each feature map independently by reducing the height and width of your input values. Okay. So we can do some max pooling and average pooling and sum pooling. These are some variants of pooling operations. See here. So previously we have taken some text. Now I am taking another text, cat sitting there. That is my word. So the word is embedded. Once word is embedded, that is transformed into a vector notation. The word is embedded. The word is embedded. This is the sentence. The sentence is transformed into the vector form. So word is embedded. Then I am taking one filter. Then I am applying same performance. I am going to apply the convolutional operation with the help of filter. Then I am going to represent one value. See, significantly you can provide high activations of 2 grams. So we call that movement we are calling. See here in the blue color you have one square rectangle here, and red color one box is there. That is called, in terms of text classification, in terms of text convolutional neural network, we call it is gram. Gram with a certain meaning. So we are transforming word to vector for similar words, similar in terms of cosine distance. Similar words and similar terms of cosine distance. Here, striding is nothing but when a weight matrix is 3 by 3, that is slide horizontally across the sentence one by one, that is capturing the information of the word at a time, capturing the 3 words. See, I'm computing 3 words at a time, so that is capturing the information of 3 words at a time. So that is what we are calling it is a stride, sliding horizontally, sliding across the sentence, sliding horizontally across the sentence. That is the process we are calling it is a slide. So this way we have to take in this one, and cat and gram. See this one. When I'm performing a convolutional operation, I generated a feature vector. From the feature vector, what is the highest information here? 0.1 or 0.3 or minus 0.2 or 0.7 or minus 0.4. 0.7 is the maximum information of that feature vector. So that is what we are pulling the information to the next layer. That is what we are calling a pooling layer. That is what we are calling a maximum pooling layer. A maximum pooling layer. I hope you understandable how I am doing a pooling operation in for text documents.
Sir, we have found the maximum pooling number, but what is the significance of that?
Highest value, ma'am.
That I got that maximum number we have found, but what does it represent? The maximum value, what is the representation? What does it mean?
Maximum information means we are collecting mostly important word sentiment. The particular word have a highest importance. That means that have a most important sentiment. That purpose only we are pulling that information. I hope you understandable, ma'am. Hello. Yes, I'm audible.
Yes, sir.
Yeah, this is another concept is a padding. Padding is nothing but, so we are not going to lose any kind of spatial information about your input data. We do padding application, right? So why do we do padding? Even though we are performing a filter, why we are going to perform a padding? Because sometimes filter does not fit perfectly to the input, your input vector. Filter does not fit to the perfectly to the input vector because of your kernel cannot perform very well on your input data. Do your padding system. So how I am doing a padding here, I will take that one also. See here, this is the inside is your vector. That is the vector representation. Then I am calculating, adding a 0. This is the padding. So that means I am not interested to lose any kind of information about my input. This is the in general of padding system. Coming to the text document, coming to the text terminology, how you are significantly represent a padding. See here, I have a 1 is nothing but a word 1. In the second row, I have a word 1 and word 2. In the third column, I have a word 1, word 2, word 3. Okay, but I am not using any kind of padding here. You coming to the next slide, so come to the right hand side, I represented 0. That is 0 nothing but it is going to secure the spatial information about that input data. Secure the spatial information about this input data. That is the purpose only we are doing. Suppose while writing a coding part of CNN model, valid padding is nothing but there is no padding. You are writing a same padding, nothing but padding, so that output dimension of the same as the input. Suppose we don't know what is output dimension. So input dimension. So what is the input dimension? Based on that input dimension, you need to initialize the padding. So that is what we are calling same padding. So while coming to that, next one is the convolutional operation followed by max pooling layer, then followed by activation function. This is the non-linear functions. Activation functions are integral component of your convolutional neural network. So here we are using popular activation function that is called a rectified linear unit, which is a non-linear function. It is not only ReLU, you have a sigmoid function. Another flavor is a tan H function, hyperbolic function. These are all called activation functions. Why do we use this activation function? This activation function can help us add the non-linearity to your input, to the learning model. So we are going to add the non-linearity to your model. That will help us to train better training of the model and initialize the significantly that weights and perform the classification task very easily. That purpose only we are adapting this activation function into our model. So this is the function here, f of x is equals to maximum of 0 comma x. So this is the mathematical representation of this rectified linear unit. F of x is equals to maximum of 0 comma x. So that is nothing but if x greater than 0, when I'm taking output x greater than 0 only I'm taking. What about x less than 0? Any input is negative, I'm not considering that is a into my model. I'm significantly representing a 0. Okay. So this is the ReLU function here. So this is the illustrative example of ReLU. Okay. So I'm taking 15, that is the positive value, transforming that equation, I'm transforming that highest value here. So what is the significant value from transforming this value, really? Okay. Finally, we have a fully connected layer. We are flattening the data, our matrix into a vector and feed it into the fully connected layer like a neural network. So then we do classification of the system. That is the purpose only we are doing a fully connected layer problem. So this is the complete architecture of convolutional neural network for text classification. So I have taken this this model, character-based convolutional neural network. This is research appeared in 2015 in the conference, and this is some text I have taken. So the text have been quantized with the help of your tokenization and otherwise word embedding system. Then you have taken a features and the length of the vector. Then convolution operation is performed, followed by the next layer, then followed by the max pooling layer. Then again I performed a convolutional layer and max pooling layers, then followed by a fully connected layer. Then finally we are going to produce a output of this input and as a classification system. Either it is a positive reviews or negative reviews, or it is belongs to which word it is belongs to which region or which word it is belongs to. That sentiment also we can recognize with the help of this architecture. This is the kind of a illustrative example of your convolutional neural network for text classification. So this is the another model. Few people are asking me, sir, why do we represent only single layer? I can also represent it 2 channels. So this is also taken another representation, 2 channels. When represented n into k representation of sentence with the static and non-static channels. I have 2 channels are there. One is a static channel, another one is a non-static channel. Then followed by pooling operation as usual. Then apply the max pooling layer. Then connect the fully connected layer. Then perform the classification task. This is another example. Okay. Any questions so far? Then we will move to the practical session. We move to the practical session. Then I will have some discussion about on data sets. Any questions so far? Any questions?
Sir, can you explain it in a layman's language using a simple example?
Yeah, sure, definitely. Definitely, I will explore to you and then I will demonstrate that example to you. So these are the data sets we have. So these are the text data sets, 20 news group, you are aware of that, which is specifically we are using classification task to map the word occurrences into 20 news groups. You can collect from that place. Another one is pen tree bank, which is also another kind of text next word prediction, next character prediction, and the broadcast news. That is the largest text data set which is used for next word of predictions here. That is also available for GitHub. Okay, here, so today I'm going to demonstrate this movie reviews classifications here. This is the CR, customer reviews. The 4th one I'm demonstrating customer reviews, classifying a product reviews, cameras, MP3 players, and etc. Positive or negative. So you can click on the link and I will share you my PPT, you people. Please click on that link, automatically will get a browser. So you can download from that place and you have to perform the task. Okay. So these are the another kind of data sets, speech data sets we have, and the music data sets we have. If you want, you can perform your research works on behalf of your various type of works. These are the popular important references or bibliography for this works in convolutional neural network handbook of this one. Similarly, exploiting the class relationship for sentiment and categorization with respect to rating scales and sentiment education, annotating expressions of opinions and emotions in language. These are the various kind of things are there. Any questions, you can write mail and definitely I will answer with you. Okay. So I hope everybody understandable my lecture. Then I will move to the lab session. Please, what you do that everybody go to your Gmail account. Then I will guide you how to do this experimentation. Everybody ready here? Everyone is ready. Then we will move to our lab session. Yes.
Yes, sir. Carry on.
Yeah. What do you do that? Everybody go to collab. So can you see my screen? Can you see my screen?
Yes, sir.
Yes,
Yeah.
sir.
Yeah, click collab, research collab. Can I share you in the chat box? So click on this button, everybody. I'm keeping in the chat box that link. Everybody have to practice here. Yes, Kavya, a spreadsheet also like unstructured data, but you are not representing in a matrix form. That means that there is no meaning or hidden patterns here. Kavya Nandala. Yeah, please go through this collab research google.com, everybody. So definitely you will get this kind of window. Yes. Yes or no? Amma, please respond from your end. You people are following me or not?
Yes, sir.
Yeah. So what do you do that? Click a new notebook. Click a new notebook and then it will display the new window for you. Click a new notebook. You have an option. Click a new notebook. Then it will transform the environment. Google Brain Laboratory, Google Laboratory, Google Research Laboratory. So someone is asked me, sir, can you demonstrate one example, one sentence, take one sentence and now you are performing that matrices. That is the question here. That is the performance I am doing here. Can you see in my screen here? Can
Yes, sir. Yes, sir.
Yeah. So after taking a new window, please go to here, connect. It is connected Google Brain. So that is the Python. They provided facility to us. It is a cloud environment. We are performing a deep learning models here. So Python 3 we performed here. I hope everybody opened your new window. Amma, please respond from your end. Then I will demonstrate one by one. Can you see my screen?
My system is taking time.
Yeah, please. Yeah. So those people who are ready for this program, just take a new cell. Already the cell is there. If there is no cell, click on this button and it will generate a new cell. Click on this button, it will generate a new cell. This is the new cell. Cursor is blinking. Just you import these libraries. Import TensorFlow as a TF. Import TensorFlow as a TF. From second library is from TensorFlow import Keras, because all text related information is stored in Keras only. So then from Keras, I'm pre-processing text import tokenizer. So just click on this button and it will execute. It is executed. So that means your credentials are correct, then it is executed. Your credentials are not correct, it cannot. Okay. I hope everybody understandable what I am doing.
Yes, sir.
Yes. Please, so this is the only illustrative example. I am writing one sentence, how I am transforming sentence into a number of vectors. Okay. So please respond, completed the sentence, line 1, then I will move to the next one.
Available online, we have to type it.
Yes, ma'am.
This file is available online or we have to type it?
Yeah, you can type in one cell. No need to waste your time. Take a one cell. Take a one cell. Type this complete information on your cell. Is it visible to you?
Yes, sir.
Okay. Everybody completed this. So once you completed, there is no errors in the your libraries. So you can have a green tick. So that is significantly represent there is no mistake in the program. I hope everybody completed this one.
Yes, ma'am.
Fine. Those who completed this, then write your own sentence. Second line, sentence is equals to the food was very delicious. This is what I take an example. No, the sentence equals to, so write the closed brackets. In the closed bracket, please write the your own sentence. Sentence is equals to, write your own sentence. Your own sentence. Write your name also. There is no difficulty. Write your name, your place, our area also. Write your own sentence.
Ma'am, how
Can you show the first
to
line once
start
again,
writing the
please?
new line, ma'am?
Yeah, I'm a sir, not a madam. And this is the code. Go to code.
Oh, sorry, sir. Sorry, sir. Sir,
Yeah,
how? Okay. Plus code.
click, yeah, plus code, and you will get a new cell.
1 minute, sir.
Yeah. Other people also practicing
fine, sir.
simultaneously. Fine. Please take a help and click on that button. Then it will execute. It is taking execution, right? Any difficulty? Please let me know, and please share your screen. Then I will help you. Any kind of help required from my side, please share your screen, then I will help you. I hope everybody completed.
Yes, sir.
Fine. So then import this line. Tokenization equals to tokenizer. This is the library. We imported through the help of keras. TensorFlows.keras we imported. So no need to specify complete sentences here. Tokenizer equals to tokenizer of number of words. We are going to keep 100. That is the library. After taking that library, fit model. So your sentence, your input is sentences. I'm fitting on fit underscore on underscore text of your sentence. Tokenizer dot fit underscore on underscore text. This tokenizer, we have to convert each word into a numerical value. The purpose of tokenizer is we have to convert each word into a numerical value. This process we are calling a word encoding or tokenization. What is tokenization in the context of CNN? In the context of CNN, the word. So we are converting each word into a numerical value. Each word into a numerical value. I hope everybody completed.
Sir, it is showing some error.
Please
Sir,
share your
doing, sir.
screen.
1 minute.
Could you share your screen? Those who are getting error.
Sir, actually, I am on mobile and I am working on laptop.
Okay.
It says it is in the first line tokenizer equal to tokenizer numbers equal to 100. And it says a keyword can't be an expression.
Keywords can't be.
An expression. Okay, I think I have used hyphen in place of underscore.
Yeah, please. System cannot understandable our mistakes, no, ma'am, please. Okay, once I am clicking that, you are getting these values.
Sir, please wait, sir. 1 minute.
Yeah, I'm waiting for it.
Yes, sir. I have got the result.
Very good. You got the same thing?
Yes, sir.
Yeah, that is enough. That is enough. Already you are representing each word and followed by a numerical variable. Each word is converted into a numerical value. Am I right? This is what you are
Yes,
performing
sir.
a tokenization with the help of tensors, keras. Okay?
Yes, sir.
Everybody completed?
Yes, sir.
Fine. So after completion of the tokenization, just what you do that, I'm doing some pad sequences here. Padding. Do the padding here.
Sir, please, Madhu sir, please share the screen.
I'm sharing screen.
No, no, not sharing, sir. No. Sharing again.
So it was visible.
Yeah, it is visible to me. I'm sharing my screen.
Sir, you please continue, sir. Your share is, I mean, your presentation is visible to us.
Okay, madam. Thank you, ma'am.
Thank you, sir. You can continue.
Yes, ma'am. Yeah, so last line, write down that, then we'll move to the original experimentation, sir. Please, this is the illustrative example. Yeah, how to, I have a sentence, how I transformed my sentence into a numerical variable and how I am doing some tokenization. So this is the input to your model. I hope everybody completed this. Just execute this line. Execute this line. I executed and I got these values. This is the sequences. Already sequences are represented, separated by commas. Padded values does not have the significance of separated by commas. So when it is not separated by commas, which is the input of your word embedding system. So next task is word embedded system we need to convert. Okay. So shall I move to the original your case study?
Sir, wait a minute.
Sir, 1 minute, sir.
Yes, yes.
Sir, I have got only one list.
Yes, ma'am.
I received only one list, not two lists.
But
There
you
should be two print.
you did not print a two list.
I have used two print statements, but I am receiving only one list as output.
Madam, in the coding or in the line, there is no mistake, madam. From your end, could you share your screen? I will guide you.
Sir, actually problem is, let me try to join from the system too.
Okay, okay. Please try to join there and definitely you share your screen. Definitely I will assist you. Okay, this is the illustrative example. I move to the original problem only. Could you permit? Then we will move to the customer review problem. I want to implement CNN. Here I did not implement CNN. Just I represented only for example of a sequence. How to we generate a new vectorization? Yeah, all of you permit me. Then we move to the next exercise.
Okay, sir.
So try to say this is the code that is enough. You can stop with the with your line and then take a new code, new line. Amma, what you do that? Go to file, everybody. Go to file, click a new notebook, click a file, go to new notebook, then practice this example. This is the case study I am representing here. Case study. I'm going to explore the case study to you. Are you able to see my screen?
Yes, sir.
So this is the classification, CNN classification, convolutional neural network classification with customer review dataset. Customer review dataset. That is the problem. Today I'm going to explore a case study on CNN classification with the customer reviews dataset. Customers review dataset. That is the input. Okay. I hope everybody received my CR dataset link. Yes or no? Everybody?
Yes, sir.
Yes. So please keep that data into your Google Drive. Everybody keep that data into folder into your Google Drive. I will assist you how to do that. I will assist you how to do that. Shall I close this problem? Because multiple tasks cannot give the chance to perform the task. Okay, I'm connecting here. So I'm performing a convolutional neural network classification with CR dataset. Okay, so this work is from this premier researcher Goldberg. So this I have taken this work. Yoquin, this is the paper we are implementing. From this paper only I implemented this CNN model. Okay, these are the libraries are required. Can you see my screen, everybody?
Yes, sir.
Yeah, please take a new, go to your file, take a new notebook, import all these libraries, Take a new file, import these libraries from your environment. Import TensorFlow as a TF, import Pandas as a PD. Pandas means we are going to create a data frames. NumPy means numerically Python. We are going to compute some calculations. We need NumPy. So next one is Matplotlib. Matplotlib is to visualize your results. Seaborn, we are going to visualize your results significantly. So we need a elegant graphs. We have to use Seaborn as a CNS. Okay, NL2K natural language toolkit from Microsoft and import random variable. And these are the various libraries we have to implement convolutional neural network for customer reviews. I hope everybody completed this import.
So what is this RE?
RE means we have to use some other purpose. I will let you know for the coding purpose. I will let you know coming to the next one. Okay. Then from sklearn under dot model selection, import k-fold validation. So no need to write all these things. Just you have to write random NL2K and from sklearn dot model under selection k-fold validation. We need to do some validation test. We are going to import some statistical library from model selection. That is what we are calling k-fold. I hope everybody completed.
Yes, sir. We don't need to import pre-tokenizer.
Yeah, no need to tokenize. I will let you know. First you completed everything. Please execute this line. Everybody, please execute this line.
We have to write this %config.
Yes, ma'am.
We have to write this %config.
Yeah. You can because so configure. We are interactive Python completer greedy method. So we are using some tags here. It is a benefit of the model. That's it. Not required. Not necessary. Okay. So that import RE is nothing but it is a rework. Actually, it is a Python has a module which is named RE to work with rig examples. Rig examples means patterns, strings, That purpose only we are using RE. I hope you understandable why we are importing RE.
So kindly repeat.
RE. So import RE nothing but it is a Python module named RE to work with rig example. Rig example means patterns. Suppose I have a pattern is equals to some string. So that string we need to handle, that library is necessary. Okay.
Okay, sir.
Okay, shall I move to the next one? Everybody completed this one, executed?
Sir, it's running.
Everybody completed and you will get this line, that is where is your Python kernel, your interactive Python kernel. Yes, everybody.
It's taking time.
No, only we are importing libraries, taking time.
I don't know. Either meeting is also going on the same system. That may be the reason.
Okay.
Excuse me, sir.
Yes, yes.
What is the use of percentile config IP completer?
So that is to configure the, see here, you can click on that configure, it will show you that it is a expose the most internal Python. So interactive Python configure system.
Okay.
It is a configure of interactive Python because we are using a cloud.
Cloud.
Okay. Where you can click on that place and it will display the things to you.
Okay, sir. Thank you.
I hope everybody completed. Yes or no?
Yes, sir. Completed.
Yes, sir. Yes, sir.
Okay.
Still
Yeah, take a new cell. Take a new cell from code. Yeah. Insert a new code cell. Take a new cell. And write configuration now. Why purpose? Specifically, we mentioned configure now. I am configuring my physical device is a GPU, not CPU. Okay, tf dot configure dot list underscore physical underscore device GPU, because GPU is there. So in the Google, people are providing a facility to us, GPU facility to us. So write down this tp dot configure dot list underscore physical device is GPU, because our data set is a higher dimensional data set. We have a huge number of records. So due to that purpose only, we are utilizing the GPU facility to compute our CNN model.
So should I share the screen with you, because the previous line is not executed till now? I don't know what is the problem.
Problem with your kernel, otherwise your system, madam.
I don't know. It's taking a lot of time.
Yeah, lot of timing means you are not simultaneously, you are parallelly open so many browsers. Please shut down all the browsers and take a new environment and please start and work with that. Okay, I hope everybody completed this allocation of your device. Is it right? Everybody allocated?
Yes, sir.
Yes, yes. After allocation of GPU, then move to the loading dataset. You are going to load dataset first here. Load dataset is, so go to this place, loading dataset. Write down crops. Where is your file? Anybody, can you share your screen? Where is your file? Pickle file. This is cr.pickle file. Where is your file?
Download, sir.
Sir, in Drive.
Where is your file? Could you tell me where is the location of your file?
Sir, Drive.
Drive. Could you share your screen? I will guide you how to do that. First, write down this all the sentences. Crops is equals to pd dot read underscore pickle and followed by path of that file. Crops is equals to pd dot read underscore pickle followed by single quote followed by path. Second one is crops dot label equals to crops dot label of a type, integer type, a string type. I'm asking a string type, integer type. Print shape of the crops. Print shape of the crops. Definitely you will get an error. Please share your screen, then I will assist you. Okay. I hope everybody completed these 3 lines.
Yes, sir.
Successfully executed, and you got this answer also 3000.
Yes, sir.
Yeah, 3755. You got it?
Yes, sir.
Okay, fine. What is 3? What is 3?
So I think columns.
Yeah, column, sentence, label, split. These are the 3. So 3775 is the number of rows. Yes, I hope everybody completed. Amma, anybody not able to perform this task, please share your screen. Anybody not performed this content, please share your screen, then I will assist you.
Sir, how I find the address? I have uploaded in my Google Drive. It's a cr.pkl.
Yeah, madam, could you share your screen, then I will assist you, ma'am.
Okay, sir.
Quicker share me your screen, Madhuri.
Yes, sir.
Where is your file, Madhuri?
So I have uploaded my Google Drive here.
Fine, your Google. Go to your code. Go to your code.
Yes, sir.
Okay, click on this box button. Box button is there, no, near to red color button. Box button, one square. No. That left hand side.
Yes. Side. Yeah. Okay.
Yeah, click that button. Click this drive button. Third button. Last one. Upper. Go to up. That button. Click on that button. Yeah, connect to Google Drive. But you are not connected to Google Drive. That is why you are getting error. Okay. You connected successfully.
Okay.
Okay, refresh now. Refresh here. Second button above. Okay, go to Drive. Click on Drive. Here. No. No.
Okay, sir.
Below, madam, below. Sample data, above sample data you have here, above sample data, click drive option. Go to my drive, click on my drive option. Where is your file?
This is CR.pk.
Double click that button. CR file, 3 buttons. Go to 3 buttons. Go to 3 buttons here. Click on 3 buttons. No, madam, please. Click on the 3 buttons and copy path. Yeah, come to your original environment. Close this one. Yeah, paste it here. No. Yes. Paste on that. Remove the older one. Yeah, now execute.
Okay,
Yes.
sir. Thank you, sir.
That's it. This is the way to do it. Okay.
Okay, sir. Thank you.
Fine. Thank you. Yes. Amma, I have a very less time. I'm very sorry to say that. So I will share you this complete code, you people, and I will go to the glance and how I performed this sentence analysis here. Okay, this is the file you are getting. I hope 3,700 and 750 rows and 3 columns here, and this is the way you are getting. Okay, you want to see your complete data information. This is the tag dot information, and it will show the how many sentences are there and what type of sentences you have. And then crops is represented by group by label, and I'm representing a label form. I'm assigning one condition here by label. When I'm labeling either 0 or 1, who are belongs to 0, sentence are split, and who are belongs to 1, it is going to split according to this group variable. So then it is going to separate the sentence and the labels. So now I'm separating the sentences and labels. You want to see particular sentence. So this is the starting sentence, and I'm going to execute the program here one by one. This is completed now. So then go to click on this button. Okay. This is also completed. This is also completed, and this is also completed. So what you do that, once completed of the separation of the sentence labels and the sentences, you want to see your sentences, take write the sentence of 0, first sentence, 1, second sentence, 2, third sentence. You want to see last sentence also, you can go for -1. Okay. So now do data processing here. I'm doing some data processing. So defining a function to compute the maximum length of the sequence. So this is the equation. Maximum length is equals to 0 and frequency of this one. Okay. So now I'm going to write the tokenization. Few people are asking me how to do the tokenization. Whatever we performed previously, I'm performing same thing. Tokenizer and FAD sequence. So doing the same thing. So I'm generating the data into this form. Then I'm doing a word index. This is not what happened in the previous slide. Word index, tokenization dot word index. Once you are doing a word index, it will represent the input of your CNN model. Okay. So it is going to take now embedding region. You are transform into embedded random variables here. This is our CNN model. This is the CNN model. See here, I'm defining a model. First, I'm defining a model. Number of filters I fixed 100. Kernel size is 3 by 3. Activation is ReLU, and my input is dimension is this one. Okay, my input dimension is this one. So then I'm writing first layer. First layer. This is the first layer, embedded layer. Your input and vocabulary size, input dimension, vocabulary size. This embedded function will take it to represent your matrix into a word matrix, completely in word matrix. That means 4,20 is there. It will represent 0.25, 0.1 like that. So that is the purpose when we are writing embedded. Okay. So then I'm writing a convolutional layer. Convolution, one-dimensional layer I'm representing because my matrix is represented one dimension. So one-dimensional layer. Filters, you are represented 100 filters. You know what is kernel size. Then followed by max pooling, and then followed by fully connected flattening function, dropout method, dense layer, and dropout method, dense layer. Why should I use dropout method? Means model is overfitting somewhere else. We do use a dropout method. Then you have to find out the sigmoid activation function. Instead of sigmoid, you can use the ReLU. You can use the tan H function also. Then compile your function. That model may be defined into this model. This is the model completion. These are the number of parameters you have, totally trainable parameters, non-trainable parameters. And then you have to test your model. You are going to test your model. This way I am going to test with tan H and all the models. Once I am testing a model, I am going to store the values. Okay. So it will generate your values. After testing the model, you are getting accuracies and loss functions. Slowly, after the session, I will share this file to you, and you have to work with the examples, and definitely will get some expertization. Okay. So these are the activation functions have been used, and accuracy also. So finally, we will generate into this model here. See this one. So these are the results. Activation function, number of filters I have used. Activation ReLU, number of filters. I have used 2, what happened? When I'm using a 3, what happened? When I'm using a 1 filter, what happened? I'm storing into Excel sheet. I'm storing it in Excel sheet, and you can observe the things. I can see this one. Okay. I will stop here, and other people also waiting for that. Okay. Any questions? This way you can execute your programs, and automatically you will perform the task. Okay. I hope everybody understandable my lecture. Thank you so much bearing with me.
Yeah, thank you so much, sir. Thank you so much, Dr. G. Madhu, sir, for accepting our invitation as a resource person, as a part of this ATAL FDP, sir. Thank you so much for giving your insights on CNN models. Thank you once again, sir.
Yeah, somebody asking question, madam. See it in my...
Yeah, sir. They're asking like how to validate the findings.
Yeah, validate. So everything is there in my system. See this one, validation. Come here. Validation here. After performing the model, we have validation task. This one, validations are, see here, validations are occurred in the model only. For each iteration, we are compiler, one command is given, no compiler command that will validate here. See, one compiler command is this. See here, tokenization compiler. This is the model is fitted into, this is the training. I'm training the model dot fit X train and Y train model batch size. So here I'm evaluating the model. This is the evaluation of the model. Loss and accuracy, model evaluation X test and test Y. So this way I'm going to evaluate my model. So it will represent it significantly. Any questions? Any questions?
Sir, what is the use of K-fold?
K-fold means, see, I have a data, 100 records are there. So first time I am going to give 10 records for testing, remaining 90 records for training. That is what K-fold validation. So that is called one fold. Suppose I am keeping K-fold means I am going to 5K, so two-fold. K is equals to 2. I am going to give 80%. 80% is training, 20% is testing. Suppose my K value is 3, 30% is testing, 70% is training. And suppose my K value is 5, 50% is training, 50% is testing. I hope you understandable what is K-fold. Am I right? Any questions?